Hey, it is time for lesson number 4, and we will be looking at Venn diagrams, and we'll try to find frequencies from a Venn diagram. So let's pretend that, I don't know, maybe we went down to Ravenna Park and asked a bunch of people, or maybe we just went up and down the hallways here at school and asked a bunch of people. And we asked, hey, do you have a pet dog? Or, hey, do you have a pet cat? Well, of course, some people might say, yeah, they've got a dog. Some people might say, yeah, they've got a cat. Some people might say, no, I don't have either one. And some people might say, hey, I've got both. Now, with a Venn diagram, everybody that I just surveyed needs to be represented exactly one time each in that Venn diagram. So everyone has to be in this rectangle. So if you said yes for dog, you've got to be in the oval for dog. If you said yes for cat, you've got to be in the oval for cat. And of course, there's an overlapping area, right? Because the dog oval is red, the cat oval is blue, and where they overlap, there's purple. And so, of course, if they said yes for both cat and dog, they got to be in that overlap area. Okay, so I've got 6, and that obviously would represent people that own a dog, but not a cat. I see a 16, that would be the people that own a cat, but not a dog. I see a 5, those would be the people that own both a cat and a dog. And then there's a 23 that's inside the rectangle, but it's not in one of those ovals. So that tells me there's 23 people that I surveyed that said, nope, don't have a pet dog, don't have a pet cat. Okay, so how do we make frequencies? Well, we got to go back and make ourselves a table like we did with the previous lesson. It looks like I've got 5 people that own a dog and also own a cat. I've got 6 people that own a dog but do not have a cat. Holy cow, here's a big number. 16 people own a cat but not a dog. Not too surprising in a city like Seattle, where you've got quite a few people that maybe they're renting property, or maybe they're in an apartment, or maybe they've got a house with a very small yard. It might make more sense to have a cat instead of a dog in a city like Seattle. And of course, 23 people, nope, don't have a cat, don't have a dog. Now it's time to make the frequencies. So how many people actually owned a dog? Well, 5 plus 6 is 11. How many people do not have a dog? Oops, went the other way. Sorry about that. How many people own a cat? Well, 5 plus 16 is 21. There comes the no dog. 16 plus 23 was 39. People that don't have a cat, 6 plus 23 is 29. And of course, the grand total has to work both ways. So if I do 11 plus 39, I better get the exact same amount as if I do 21 plus 29. And so it looks like I surveyed 50 people. And now from my survey, if I truly did a random survey and really got people at random, I can then generalize this and say, hey, I bet for the people in Seattle, this will be true. So the probability that someone in Seattle owns a dog based off of this sample Well, 11 of the 50 people I talked to said, hey, they got a dog. Probability that a person does not have a cat? Oh, it looks like 29 out of 50 people do not have a cat. A person that doesn't own a dog owns a cat. Gotta be careful what rows and columns I'm looking at now. Right? It's contingent that they don't own a dog. So I have to look in the no dog row. So that's why we gotta use that grand total of 39. So 16 of them own a cat among the non-dog owners. Okay, when we first did this, we did a lot of drawing of trees to figure out the size of the sample space. But for today's IXL, you'll discover that instead of drawing a tree diagram for each one, it's just easier to multiply. So if I've got 5 different shirts, 3 different pairs of pants, 2 different pairs of shoes, how many different outfits do I have to choose from? Again, I could make a tree diagram. Alright. Start by picking which of the 5 shirts to wear. After picking which of my 5 shirts to wear, I could figure out which of my 3 pairs of pants. Finally, which of my 2 pairs of shoes. And then I can count. Or I can say, hey, you know what? Instead of trying to count all those ends of all those branches, 5 times 3 times 2 is 30. And sure enough, if you count, there are 30 ends on those branches.
I'm ready to go and everybody else is.
But this only works if the events are independent. Then we use the counting principle. And it looks like American Gothic this time has been taken over by SpongeBob and Patrick.